Continuing today with polynomial division. Type of division we are going to do is synthetic division. We learned simple division, long division, and then we are going to today learn about synthetic division. So our synthetic division is whenever we have a polynomial divided by a linear binomial. So binomial meaning two terms, and linear meaning that x is to the first power. So when you do this setup, you want to still make sure that you have all your powers of x accounted for. If you are missing a power of x, you want to make sure that you put a placeholder in for it. So if you look at this one, we have x to the fifth power, but we're missing x to the fourth power. So we're going to need a placeholder for that. But then we all have third, second, first, and then we have our constant. So when we go to set this up, we just have to be sure we put in that one placeholder for x to the fourth power. When you set this up, you're going to make a little half box there. The number that goes in this box right here is going to be the number that makes your divisor 0. If you can't just look at it and see what that is, then you just kind of go over to the side and you set it equal to 0 and you solve it. So for this one, I would have to add 3 to both sides in order to solve this and see what x is. So x equals 3. That's the number that I'm going to put right here in my little box. The next thing you do for this setup is you list the coefficients of your polynomial. Only the coefficients, and you want to take the signs with it. So the coefficient of x to the fifth is 2. So you write down a 2. The coefficient of x to the fourth, well, since x to the fourth is missing, the coefficient is 0. Coefficient of x to the third is -1. X squared has a coefficient of 3. X to the first has a coefficient of -2. And then our constant is 7. And then you're going to leave a little space here where you're going to write some more numbers, and then you're going to draw a line. So this is called synthetic division. So synthetic means fake, right? So we actually aren't doing any dividing here. We're going to just be multiplying and adding the whole time. Your first step is to drop down this first number. And then from there, you're going to start just multiplying and adding and multiplying and adding. So you're always going to take the number that's in the box here and you're going to multiply it times the number that's on the bottom there. So we're going to multiply. So 3 times 2 is going to give us 6. And then you're going to put that answer right here. The next step is to add. So straight down the column right here, you're going to add. So 0 plus 6 is going to give me 6. And then you start all over, and you just keep doing that until you run out of numbers. So you take the 3, and now you're going to multiply it times your 6. 3 times 6 gives me 18. So I'm going to put my 18 right here, and then you're going to add down the column. So -1 plus 18 is going to give me 17. And then you're just going to continue with this process until you run out of numbers. So now I'm going to do 3 times 17. And I get 51. So I did 3 times 17, and that gives me 51. And then I add 51 and 3, and I get 54. Keep going. 3 times 54 is going to give me 162. And then we add these two numbers together. -2 plus 162 is going to give me 160. 3 times 160 That's going to give me 480. And then 7 plus 480 is 487. Okay, so this bottom row, these are going to be all the new coefficients of your quotient. So if we had to start with, we had a 5th degree polynomial here, and we divide it by a 1st degree polynomial, that's going to give us a 4th degree polynomial. So your polynomial here, this is what we call a depressed polynomial, because it's depressed down by 1 power. So this is going to start 1 power lower than you started. So the answer is 2x to the 4th plus 6x to the 3rd plus 17x squared plus 54x plus 160. And then this last number here, this is our remainder. So we're going to write our remainder just like we did when we were doing long division. This is a positive 487. So we would put plus, and we're going to have a fraction, 487 over our divisor, which was x minus 3. So you're still going to get an answer very similar to when we do our long division, where it's just another polynomial, but this process here is a little bit easier. And once you get really good at it, it actually goes pretty fast. So let's do one more example. This one's a little bit shorter, so I'm going to check out my polynomial here, make sure I'm not missing any powers of x. So this is from 3, 2, 1, and my constant. So this one is good to go. So do my setup. The number that goes in this box right here, or in this box right here, we're going to take our x plus 4, set it equal to 0, and we're going to solve that. That's the number that goes here. And then we take the coefficients of our polynomial. We already determined that we don't need any placeholders, so we're just going to line up our coefficients. 3, 4, -2, -1. Drop down that first number, and then you're all ready to go. So you're going to multiply on the diagonal, and then you're going to add the columns. So you're going to do -4 times 3, and you get -12. 4 plus -12 is going to give us -8. And then we're going to take our -4 times our -8, and we get a positive 32. Add these together, and we get 30. And then -4 times 30 is going to give us -120. Add these two together, and we get -121. So you just multiply on the diagonals, and you add on the verticals. And then this here is going to start off at the second power, because this was the third power. Dividing by the first power, 3 minus 1 is going to give us 2, so it starts at the second power. Another way you can think about writing your answers, if you read it from right to left, this number here is my remainder, my constant, x to the first power, x to the second power, so on and so forth. If I had more numbers here, then my powers would just keep going up. So your final answer, 3x squared minus 8x plus 30, and then we have this constant, or this remainder here. It's a negative number, so we're going to have minus the fraction of 121 over x plus 4, because x plus 4 was our divisor. Whoops. The x plus 4 is what goes on the bottom of that fraction. So, okay, let me know if you have any questions.